This video is about making silver-silver chloride electrodes out of silver wire. It corresponds to section 39.5.3 of the Applied Analog Electronics textbook. Now, the whole point of making a silver-silver chloride electrode is to take the silver wire and to put a coating of silver chloride on the surface of the wire. There are two ways to do this. One of them, which is the very popular way to use in wet labs, is simply to soak the wire in a solution of sodium hypochlorite. Now, sodium hypochlorite is a very easily obtained reagent. It's ordinary household bleach. So that household bleach is about an 8.5% solution. If you just soak the wire in bleach for 15 or 20 minutes, you'll get a nice uniform coating of silver chloride on the wire. I've done that for this lab and it works just fine. There are some problems with doing that when we're working in the electronics lab because bleach is a really nasty substance. In the electronics labs, we do not have sinks to clean out beakers and stuff. We do not have eye wash fountains if anybody splashes bleach in their eyes. And if people splash bleach on their clothes, we don't have lab coats and stuff in the electronics lab. So bleach is not necessarily the best thing for us to be working with in the electronics lab. If you're working at home, you can put on old clothes that you don't care if they get bleach spotted. You can work in the bathroom where you've got sinks to clean up any spills, have some rags handy in case you spill any bleach. You can do it all with wet lab techniques at home. But I'm going to show you also the technique that we use normally in the electronics labs where we do not want to deal with anything as dangerous as bleach. And that is we do electroplating. And the idea is that if you've got the two electrodes and you put them in a salt solution and run a current through it, well, what happens is one electrode, we have electrons coming off the wire, silver chloride being removed from that wire, and chloride ions going into solution. And on the positive electrode, we have the chloride ions coming out of solution and making silver chloride on the surface of the electrode. Now, if you don't have silver chloride on one of the electrodes, then you're not going to be able to remove the silver chloride from that electrode, and you'll get a different reaction there, perhaps a hydrogen reaction. But you can still get a current flow between them and get silver chloride plating on one electrode. So if you do this, the positive electrode will pick up silver chloride, the negative electrode will lose silver chloride or make some other reaction. Okay, so how you do this thing normally is put the two electrodes, if they're just plain silver wire, put the two electrodes into the solution, run a current through it. And you want to control the current because the current is basically telling you for each electron that goes in, that's one chloride ion turning into silver chloride on that. So the time that you spend with a given current tells you how much silver chloride you've put on. And usually you want to control this so that you don't have other reactions happening and don't make a really large current. So there's some calculations to do in the pre-lab to estimate about what sort of current you want. For the wires I'm using, I'm going to say let's aim for, say, a milliamp, just to be definite. I set up a system here. Let's look at the desk first. I set up the system here with the two wires to the electrode and a series resistor of about, here I used a 2 kilo ohm resistor. 1 kilo ohm might be handy because then 1 volt across the resistor is 1 milliamp. It's very easy to interpret the readings you get. I use 2 kilo ohms for no particular reason. And then I have the power supply across that series chain, and I use channel 1 across the electrodes and channel 2 across the resistor to measure the voltage and the current. And if we look at what we have here, the two wires, each one is wrapped starting at the ear, wrap once around the ear, go back down through the armpit, and then go back up to the ear, wrap it around again. Now I've got really long wires here that give me sort of long dangling tails. You probably won't have enough silver wire to do that. Silver wire is expensive, so we only shipped you enough to do just the electrodes wrapping around the ears of the holder here, and not enough to have long tails as well. Okay, the positive one here should be picking up silver chloride. The negative one should be losing silver chloride. I immerse it in salt water. I'm actually going up past the shoulders of that holder so that the whole part of the wire that I will be using as an electrode is getting the electroplating. Okay, and then there's two things I can do here. I can use the voltmeter to look at the two channels, and I can use the power supply. Let's start with, say, 2 volts and see what we get from that. Start the voltmeter. When I start the power supply, what I'm hoping to see is that on channel 1, I'll see a few hundred millivolts across the pair of electrodes, and on channel 2, since there's a 2 kilo ohm thing, I want to see about 2 volts, maybe to get a milliamp. So let's see what I got. Turn it on. I'm getting 1.96 volts. Well, that's pretty close to the 2 volts, and I'm getting about 48 millivolts across the other pair. And that seems to be working okay. I'm not seeing any bubbles or anything happening here because I've got silver chloride on both electrodes. I'm basically just stripping it off, the silver chloride off of one electrode and putting it onto the other. The way you would do this, you start with 2 silver wires, is you would run it like this for a fair amount of time, making sure that you're getting a reasonable current, and you'll probably have a larger voltage drop across the electrodes if you just got silver wire and not silver chloride already on your negative electrode. Run this until you get quite a dark electrode on the positive electrode, and then swap the wires to strip off silver chloride from the what was the positive electrode and put it onto the other electrode. And you'll want to run that second electroplating for half as much charge, because you want to strip off half the coating and put it on the other one. And let's stop this now and take a look at what we've got. It usually takes a fair amount of time to do this, 5 minutes, anywhere from 1 minute to 10 minutes, depending on things like how clean your electrode is and how much current you're putting through it. All right, let's take a look at this. Now you can see this electrode has gotten, it's not too easy to see on the video. I can see in person that the electrode that I was stripping, the negative one here, has gotten paler and the other one has gotten darker. They're still both reasonably coated, so I could stop at this point and say, hey, I've got my electroplating done. Of course, since I started out with ones that have been soaked in bleach, my plating, which was chemically plating instead of electroplating, was done before I even started. Do make sure that if you do use the bleach solution, that you rinse your electrodes off thoroughly afterwards, because you don't want that bleach to be contaminating the salt solutions that you're going to be measuring. Okay, that's about it for electroplating. Let's do another video on how to do the measurement in a little bit.